Day two. Rock, paper, scissors. So this one on the face of it, she says, looks reasonably straightforward. I think that one of the things that I'm going to start to try to do is just think a little bit, try to get inside the mind of the person setting this problem and see if I can come up with some predictions as to what the second part will be. And the reason I want to do this is because I've only got kind of half an hour to code each one. And the more that I can use the first half an hour to prepare for the second half an hour, that's just sort of write it in a way that will be suitable for the next part, the better off I will be in the later steps, which may become quite important as I start to run out of brain power, which may happen fairly soon. So just a reminder of the rules. So I can plan as much as I like, but I can only spend half an hour per step coding, so an hour total per day. And there are a few other rules which I put in the description, but that's the main one. So with this one, we've got essentially your rock, paper, scissors game, where A is, what's A? A for rock, B for paper, and C for scissors. And this strategy guide tells us which, if A is played against us, we should play Y, and Y is, so in this case, X, Y, and Z in the second. So we've got a list of pairs, where in this case, if the opponent chooses rock, so in the first round, if the opponent chooses rock, then I should choose paper. Or rather, in the first round, my opponent will choose rock, and I should choose paper. And then I need to calculate the score for this round, which is there's a number per shape. So 1 for rock, 2 for paper, 3 for scissors. So scissors is worth more for some reason. Who knows why? And the outcome of the round, which is 0 if lost, 3 if drawn, and 6 if we win. And then we add the score for the item and the score for the round together. And our job is to calculate the total score if everything goes according to the strategy guide. So let's first just come up with a bit of a sense of what sort of program we're going to write for this, and then let's try and think about what the next step is likely to be. I can already see a few ways that it could expand and get more complex. So let me zoom in a little. So if we're going line by line, this is our sample input, and we're going to go line by line and calculate 2 things for each one, which is, so this is the sequence, the score of move score. So that's the score of the thing we've chosen, which is in this case Y, X, and Z. So we want to calculate, we want to have a function which goes from Y to, I don't know what it is. It's 1 for, I hate this stuff. Why does it have to be so difficult? Okay, X is 1, Y is 2, and Z is 3. So X is 1, Y is 2, Z is 3. So we want this function here, and we can use this to calculate. In this case, it'll be 2, 1, and 3. And we want to calculate the round score or round prize, let's say. This was a prize score, let's call that. And then for this one, it's we need to work out whether we win or not, which will involve writing a function like calc prize score, which will need to, and if you've studied at Makers, which is where I work, you'll be familiar with writing this. And actually, I can't remember what the right algorithm is now. Anyway, it's gonna who wins, calculate win, lose, draw, win, score. What is it? 0, loss, 0, draw, 3, win, 6, which means we then need a kind of we need an algorithm for the sort of lose, draw, win, which roughly works like if equal, draw. Is this too codey? Can't be code if it's English. If it's equal, then draw. And then we're going to have a dictionary which maps from yeah, that wouldn't be so hard. A dictionary that goes from an input let me write this out. So it's something like rock defeated by paper, paper defeated by scissors, defeated by rock, and then you look things up in this table. Otherwise, look up my move in, let's call this something. In winning map, and if the outcome is my opponent's move, then loss, otherwise win. Okay, that's a bit messy. I'm sure there's probably a nice way of doing it. Okay, and then we can take that back and we've got here, and then we get the prize score. So let's just run that through a couple times. Let's say we've got, all right, fine. So another thing I'm noticing is we're going to we're going to get confused, all these A's, B's, Y's, X's, and Z's. So we need to figure out what to do about that. Do I try and keep them in the source format, or do I try to normalize them? I don't think it makes a huge amount of difference to this, because we could say instead, so rock, paper, let me actually write this out. A, B, C, X, Y, Z. Rock, paper, scissors. So C is scissors, and then rock, paper, scissors, paper, scissors again. So that's the table for that. And so if it's my move, which is going to be the so my move would be X, and that would be defeated by B. This move would be Y, and this would be defeated by C. This one would be Z, and this one would be defeated by A. In which case this algorithm needs to change, because we're not going to be able to we're not going to be able to equate these. So that's okay. That makes it more interesting. But so, okay, here's an architectural decision which could bite us later. Let's say instead we've got X, Y, Z. A, B, C. In this case, it's rock and rock is draw. So these are draw. X and so rock, and if my move is rock and their move is paper, I lose. If my move is rock and their move is scissors, I win. If my move is paper and their move is rock, I win. If my move is paper and their move is scissors, I lose. If my move is scissors and their move is rock, if my move, okay, so I play scissors and they play rock, which means I lose. If my move is scissors and their move is paper, I win. Okay, so if I have a dictionary like this instead, then I can look up my move and their move, and I'll get the outcome, which will then allow me to really go straight to, I could then essentially go straight to these numbers. So in this point, we get look up my move, then theirs in this table, which I'm going to call outcome table. Get rid of that, and I can keep this over here. Don't need this. And then this gets me, I think, pretty much all the way there. So let me try and run this out here. Okay. And I can actually have, yeah, I've got this table already, and I've got this table. Is their move, is the value of their move going to be important? The shape you selected, fine. Okay, so I only care about that. So in which case, to calculate the prize score, we take A and Y to make 6. We take B and X to get 0, and we take C and Z to get 3. And then we sum these up to get 8, 1, and 6, which comes out to be a total of 8 plus 1 plus 6, which is 15. Is that right? Yes. Okay. I am somewhat convinced, which means we need to think about how this is going to change. We don't need to, but I'd like to. So let me just, I don't think I want that. I'm just going to keep it there just in case. So if we call this step 1, how could step 2 change things? Well, we've been given a bit of a hint or red herring. I'm not 100% sure. We don't know if this actually is the winning strategy guide. So we could be asked to check a number of different. No, that's probably too simple. Anyway, let's write it down. So ways it could change. Need to check a different strategy. We could get asked just to do more. I don't think that would be checked. So the complexity of this would be the big O complexity. Again, I'm not like a big O. I'm not super adept at causing that, but I think it's linear. So it should complete in linear time and linear space, I think. Yeah. So we might need to change the meaning of the symbols. What could really screw up this algorithm? Well, we could end up with like more symbols. I think the puzzle input doesn't change from step to step. So I mean, I don't think it does anyway. So I don't think that's likely to change. This calculation could become more complex in some way. Or I might need to calculate the other side of the bargain, like the other score. Let's get a sense for the input size. It's quite large, but not impossibly large. Anyway, I don't think I'm going to get any ideas about this. Let's start coding. So what am I going to do first? I'm going to reshare my VS Code. I'm going to get the input before I start the timer. Okay. I'm going to create the file. Myself this. And I think actually I'm going to come up with a little bit of an idea as to the order I want to tackle things. I think I'm going to first drive out the outcome table, drive out the calc move table, then write the main loop. Okay, let's get started. Right. Always got it on the wrong indentation and the wrong settings. Yeah, okay, fine. No, mine, I'm actually going to shift this. It'll be easier. Okay, theirs being A, mine being X should equal 3. A 0, nope. Y, Z 3, 6, 9 should be 0, 3, 6. And 6, 0, 3 according to my table. All these should fail, and then let's go with a I can probably be faster at this. Gonna need to start being faster at this. No, that's not going to help. Okay, 9. E 0, 3, 6. C 6, 0, 3. Okay, that's that first bit. This is probably unnecessary. I probably need to be more pragmatic about this. But it's called no screw-ups for a reason. Okay. I'm actually also going to put in the trial input, which is A, Y, B, X, C, Z. Gonna How did I do this yesterday? Okay. This and then while true, if not line break. I don't know what that's about. Now I want to assert calculate trial .txt should be 15. Okay, I'm not looping. That's why. Okay, fine. Now I want to have a running or a total score starts off at 0. And then total score, well, round score equals the sum of calc move score with, okay, so I've got to break this up. There's mine is line 3. So let me print that out. Okay. Two and 3, that's right. And it's theirs first and then mine. Okay, 603, that's right. Eight, 1, 6, and the total being 15. Okay. Oh, it's not returning it. That's why. Okay. So we've got the assertion passed, and then the total, the right output we've got is this. So let's try that in the checker. Okay, too high. Right. Just check I've got all the items in here. CX, BZ. CX, BZ. Okay. Right. Total score if everything goes according to the strategy guide. What time are we on? Okay, 20 minutes. All right, so I've got a decent chunk of time to figure this out. How many lines am I going through? Am I going through all the lines? $2,500. 25, that's all the lines. Okay, the score for a single round is the score for the shape you selected one for rock, two for paper, three for scissors, plus the score for the outcome of the round, 0 if you lost, 3 if the round was a draw, and 6 if you won. Let me go back all the way to the start on this. Oops, wrong one. Okay. Four plus 9 is 13. Too high. Okay, so I've checked all of the possible round outcomes, but the example doesn't. So A and Y are definitely good. B and X are definitely good. C and Z are definitely good. So what about A and X? So A would be they play rock and I play they play rock and I play rock, which should be a draw, which is 3. That's right. Okay. They play rock and I play scissors. Okay. They play rock and I play scissors. which should be 0. That's the error. 3, 6, and actually that's in my table as well. 360 036 603. All right. That's probably why then. Silly, silly mistakes. Okay, I need to get better at finding those. All right. Will this be the right one? Yes. Okay. 14 minutes and 30 seconds thereabouts. Okay. All right. That was a bit sketchy. All right. So, okay. A silly mistake. So what I should try is I should try looking for some more assertions I can do. Like if I know that each row and column, like if I know that all of these should add up to such, such, and such, then I can use that as an assertion. I can do a sort of cross check on it. That'd be easier. That would help me stop making silly mistakes. Okay. Part 2. The elf finishes with the tent, finished helping with the tent, and sneaks back over to you. Anyway, the second column says, yeah, okay, how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. In the first round, your opponent will choose rock, and you need the round to end in a draw. So you also choose rock. In the second round, your opponent will choose paper, and you choose rock, so you lose with the score of 1 and 0. In the third round, you will defeat your opponent's scissors with rock for a score of 1 plus 6 equals 7. Now that you're correctly decrypting the Ultra Top Secret Strategy Guide, you will get a total score of 12. Following the elf's instructions for the second column, what would your total score be if everything goes exactly according to your strategy guide? Okay, so what did I miss? I didn't see this. Well, I kind of knew that your own it was weird to count your own move as part of the score, and now I get why that's in there, because that's kind of important here. So maybe I could watch for things like that in future. So we need to reverse out a bit of the logic. Okay. Right. Fine. So let me get rid of all this stuff for the moment. Go back to my sequence table. So in theory, I can still use most of this if I can work out what my move is going to be. X is lose, Y is draw, Z is win. Okay, we'll write that down. X, lose, Y, draw, Z, win. So I can't know the move score yet. I can know the price score, but it might just be a bit easier to just say, if I can calculate out see, now I've hard-coded in my own. It's very irritating. Okay. So my move in this case, we need to go from, so their move is A, which is their move is A, which means my move, if I need to get a draw, my move also needs to be A. Their move is B, which is paper, and to get a lose, I need to, so B being paper, paper loses against scissors, which means my move needs to be Z, the scissors one. And if their move is C, which is scissors, and I need to win, I need to choose rock, which is X. So that would be AZX, which A opponent chooses rock. I also choose rock. I choose rock. I choose rock. Okay, well, I've gotten all that wrong. So in all cases, I choose rock. Okay, let me just write this. Stop using these silly numbers here. I'm going to get rid of this. So if my opponent's chosen A and I need to draw, I need to choose rock. If my opponent's chosen paper and I need to lose, rock loses to paper. If my opponent's chosen C, which is scissors, and I need to Z win, then I need to choose rock, of course. Okay, that makes sense. So I can probably do this with another table. X, Y, Z, A, B, C. How did I do that over here? Yeah. So in the case of A and Y, I need to choose rock. I should get rid of these. I need to choose rock. With B and X, I need to choose rock. With C and Z, I need to choose rock. With X, to win against rock, no, to lose against rock, I need scissors. I'm going to need to check all of this. To lose against rock, I need scissors. Rock kills scissors. Okay, fine. To lose against scissors, I need paper. To draw against rock, I need rock. To draw against paper, I need paper. To draw against scissors, I need scissors. To win against rock, I need paper. To win against paper, I need scissors. And okay. And so we end up with these sort of rules. Each one has to have R, P, and S, R, P, S, R, P, S, and each column also needs to have RPS, RPS, and RPS. Okay, so we're good with that. Okay, so if I look up A and Y, I get rock. If I look up B and X, I get rock. If I look up C and Z, I get C and Z, I get rock. Okay. And I can also go from, I don't think I'm going to reuse it because I think I'm at risk of confusing myself. Price score should actually now be X is 0, Y is 3, and Z is 6. Total being 0 plus 3 plus 6, which is 9. And so to calculate this, I get my move. I can calculate the move score, which will be RPS, which would be rock, paper, scissors. I'm pretty sure that's true still. Rock, paper, scissors. Okay, great. With the total being 6. So if we go through all these, okay, so the algorithm is 1, look up my move in score in my moves table. 2, calculate move score, or look up move score. 3, look up prize score, which should be easy. 4, add all together. 5, sum over lines in file. Okay, so let's look up the move. A and Y. A and Y is R. The move score is 1. The prize score is 3. And the sum is 4, obviously. Okay, I've done all that. B and X is R. The move score is 1. The prize score is 0, making 1. C and Z is R. Move score 1, obviously. Prize score 6, making 7, which makes a total of 4 plus 1 plus 7 is 12, which I think is exactly the right number we get in the sample. And it is. Great. Okay. So how am I going to go about this? I'm going to drive move table cross check to drive prize score 3 drive move score 4 drive main loop 5 apply to input. Okay, let's get to it. Is there anything that actually, because there anything that could go wrong here? Probably. Wish I had more sample inputs. The move table could be wrong. That's probably the first thing that could easily go wrong, because I've had to do a lot of that in my head. Is there a way I can just triple check that? Let me try going the other way. So scissors. So if I have, okay, let me do this. If I play paper, so I play paper against scissors, I lose. So this is the losing row. Let me just note that down. Losing, drawing, winning. And this is rock, paper, scissors. Yeah. Okay, if I play paper against scissors, I'm going to lose. If I play rock against paper, I'm going to lose. If I play scissors against rock, I'm going to lose. If I play scissors against scissors, I'm going to draw. If I play paper against paper, I'm going to draw. If I play rock against rock, I'm going to draw. If I play rock against scissors, I'm going to win. If I play scissors against paper, I'm going to win. If I play paper against rock, I'm going to win. Okay, nice bit of a, what are they? Somatic reasoning there. It's very, Pape, Seymour, Mindstorm Sky, logo, very logo logic. Okay, all right. Now we're going to get into it. Let me just put my notes across here. All right. I'm not going to reuse anything because I'm just going to get myself confused with the different meanings of the symbols. Okay. Timer to start. Go. Move table. Okay, I didn't decide which one to have first. I think A and then X, so columns first. So A, with Y, A with P, B, C, and this is going to be scissors. So A and X is scissors, A and Y is rock, A and Z is paper, B and X is R, B and Y is paper, B and Z, no. A and Z is paper, B and Z is scissors, C and X is paper, C and Y is S, C and Z is rock. Okay, and so we should end up with each of these groups: rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. This should be all A's, all A's, all A's, X, Y, Z, X, Y, Z, X, Y, Z. Okay, and if we try to group these in a different way, RPS, RPS, RPS. Okay, that's great. Brilliant. Yeah, okay. Okay, that's step one done. Zero, 3, and 6. I'm gonna have to find a fast way of doing this. One, 2, 3. Okay, that's good. I can steal this bit. No, I'm not going to worry about that. Okay, so to calculate this, I want to get the, see, I'm in the wrong mode again. I need to configure my editor properly. Okay. So at this point, I need to get theirs, which is line 0, outcome, which is line 2, and I can print that out by stealing this. I'm going to take this as well. Don't know why I even put that in there. Okay. A, Y, B, X, C, Z. Okay, great. Then I need to look up mine in the move table with theirs and outcome. Yep, that looks good. Now I need to look up the move score for mine. Oh. Usually better at naming. 1, 1, and 1. Okay, that's right. Three, 0, 6, and that's correct. Round score is move score plus prize. 4, 1, and 7, which is what I've got in my table. And we want to add the round score to the total, which gets our assertion to pass, and now we can pass in the input. Ten, 4, 9, 8. Okay, let's try that out. Okay, right answer, and 2040. So 9 minutes and 20 seconds or so. Perfect. Okay, that's day 2. I think I'm still going to need to get a bit faster, and I might want to start thinking about this tabular process that I've got, unless it totally gets ruined later. Anyway,